native plants for fire-resistant landscapes. All right, guys. Well, thank you for having me come up virtually up there. It's such a long state. We're kind of like two different states joined by a common flora, you know. And I have a real affinity for Northern California. Actually, my nephew lives right in Berkeley, goes to UC Berkeley, and my brother lives in Dublin. So I love it when I can get up there. And we put together the slideshow because we've had about 30 landscapes go through actual major fire events. And we've learned a lot from it, and I'm eager to share that information because, you know, knock wood, we haven't lost a single house yet. So we're going to talk about, you know, kind of general horticultural protocols for working with native plants. And then we're going to get into the specifics of fire ecology and fire resistance. And then we're going to talk about this 5-year study that we just finished with Dr. John Keeley for the U.S. Navy on this concept of fire-resistant California native landscapes. So without further ado, I'll get going here. Now, why are you acting up? Come on. There we go. Okay. So there are sections I'm going to go through pretty fast because it's kind of a very dense presentation and can take a while. So I'm just going to try to get through it as quickly as I can and get to the main points on fire. Just a little background. Thank you for the nice introduction, Sue. I was a former aerospace engineer, and I turned very logically, career-wise, to become a landscape contractor 25 years ago. And haven't regretted it. And we've been responsible for over 750 native landscapes in Southern California. And you wouldn't know most of these, except you might recognize the infield of the Del Mar Thoroughbred racetrack. So that was a fun, large project. And as Sue mentioned, we've written a couple of books, and this one came out in 2016, the first in 2013. So most of the plants that we're talking about, and the ones we tend to use in California native landscapes, you know, are from our Mediterranean plant communities, including chaparral, coastal sage scrub, and oak woodland. We really use plants from all our different plant communities, but those are the predominant ones, and fire is a part of that ecology. And fortunately, there's a lot of threat to these native plant communities. One of which is land abuse. You know, you look at this picture and you might think that you're looking at oak savanna. Well, actually, no, you're looking at cow pasture with some oak trees in it. Because this was once covered in coastal sage scrub and chaparral, and then they burned it off or used chains and removed it so they could graze it. And this is a type conversion that's been going on for centuries all throughout California, and why we're losing so much of our natural habitat. Fuel reduction is another threat to chaparral. They have a lot of carbon credit money they want to spend. So agencies will go into the middle of nowhere as opposed to working around communities and do something like this in the name of fuel reduction. And of course, you guys probably know if you do this kind of clearing on this scale, you end up with this. And when you end up with this, you actually end up with a worse situation that is extraordinarily flammable and very erosion favorable, and also almost no habitat. These are flashy fuels. They're ready to burn every August, and they go up instantly. And in fact, to call this an ecosystem preserve is kind of disingenuous because there is no ecosystem left here. There's been so many fires. You can even see the erosion reels in the upper left corner there because there's just no ecology left. And what people don't realize is that chaparral can actually be eliminated by the wrong kind of fire. It's not made to burn. Chaparral is not designed to burn. It does not need to burn. Okay, I know that might be a profound concept, But chaparral needs to burn like your house needs to burn because you have fire insurance. So here's what happens when you burn it too frequently. In 1970, the Laguna fire came through here, and in the far left there, that was all the burning that chaparral experienced, and it recovered nicely. Unfortunately, it burned again in 2001 in the middle section, and again in 2003, and you can see there what was once beautiful, thick, healthy chaparral is now weedy cow pasture. It's just non-native garbage. And this photo was taken about 2008 or 9. So not much left, and that's what's happening. And this is what's happening too. You know, you're taking beautiful verdant chaparral and turning it into this, okay? Unfortunately, this is what people think is native to California. This is what our California plant communities look like. This is what our native landscape is going to look like. But you are absolutely looking at a burned out shell of its former self, and it's actually a process of desertification that's going on, because as we lose our shrublands, we lose our humidity, and it's replaced by non-native annuals that are lignin, cellulose rich, and completely desiccated by the end of summer. There's only a few native, highly fire adapted species that can tolerate it. So I also want to make the point that being dense and impenetrable and prone to huge intense fires is the natural condition of chaparral. It is not the fault of conservationists nor past fire service suppression policy. There's this myth of fire suppression going around that we're somehow suppressing chaparral fires. Now, I'm not talking necessarily about ridgeline pine forests. I'm talking about the chaparral. You don't suppress chaparral fires. You get out of the way and you set up defensible zones around communities, hopefully, and you do the best you can to defend against them. And their fire frequency that most experts would agree on, I actually think it was greater than this, is about once every 30 to 130 years. Bert Wilson in Las Politas, who was also a CAL FIRE fireman for 14 years, feels that the fire frequency was more about every 50 to 200 years. And really any higher than that 30 to 130 years, you completely lose the ecosystem. The presence of the ecosystem itself is evidence of a lower fire frequency. And when you think about it, you know, we're talking evolutionary time scale. Chaparral is millions of years old, okay? Humans have been around for about 15,000 years. So people like to talk about all this indigenous burning, but yes, it occurred, but you know, on the evolutionary level, things were evolving long before humans showed up. And so when you take humans out of the equation, what are your ignition sources, right? Well, natural. Lightning. Lightning, somebody say lightning, or maybe volcanoes, okay? I mean, there weren't many ignition sources, and certainly in Southern California, how often do you have lightning storms during Santa Ana wind events? It's getting really weird up north there, where you're having these lightning storms immediately followed or during these offshore flow events. It's bizarre, and it's leading to these horrific fire events that you're seeing up there. Down here in Southern California, they're primarily wind-driven events during Santa Anas, and you don't tend to have lightning storms during offshore Santa Ana events where the humidity is less than 10%. So yeah, so indigenous burning would have had very little impact on the actual evolution of chaparral and its fire behavior. So the vast majority of fires in contemporary times are human caused. I mean, this is a startling figure. 97 to 100% of all Southern California fires in all counties were human caused from 1919 to 2016. 97 to 100% going county by county. And some common ignition sources are arson. Yes, you've got a lot of unfortunate people running around who are lighting fires for their own pleasure. You have a lot of problems with electrical fires. Certainly a lot of our big fires down here were related to arcing and down power lines and transformers. Smoking, hopefully this is becoming less of a cause, but still people starting fires by flicking their cigarettes. This is a huge one, guys. Sparking landscape equipment, lawnmowers, edgers, machetes, all of which can hit rocks or metal objects and spark. And I just implore people, especially contractors, if you're gonna go out and you're gonna be weed eating, you're gonna be mowing, you're gonna be doing any kind of field treatment, have some form, some source of water nearby. Even if it's a couple of 10-gallon drums, something you can throw on these fires when they get sparked. It's amazing how often these fires are sparked from landscape equipment during the summertime. People burning trash. We had a huge fire, burned up half of Palomar Mountain by some guy who decided to burn his trash in Lake Henshaw in the middle of a Santa Ana event. Cars, bad catalytic converters. You can tell this because you'll see these little fires starting at very regular intervals along the freeway. And as catalytic converters die, they'll often spew out hot debris that will start fires. And of course, children playing with fire. This is an old one. You just wouldn't think this would be such a problem, but in 2014, they burned up half of North County, San Diego. It was a 14-year-old girl running around lighting fires. So in order to deal with this, most agencies have set up a zonal approach that encompasses the first 100 to 150 feet around the home. Zone 1 is usually that first 30 to 50 feet. And Zone 2 or B is usually 50 to 70 feet outward from there or even more. And Zone 1 is probably the most critical to defensible space. It's when you have a fire in your neighborhood, the crews will come up and they'll actually make an assessment and they'll look at your property and say, well, can I actually safely defend that house or not? Because I really don't want to die defending your possessions, okay? And they actually make conscious decisions as to what properties they will defend, okay? And one of the great causes of fire in this first zone are flying embers, or sadly to say, burning animals. I tell people who have this fire fetish that really think things need to burn, well, what does that do to habitat, guys? You know, it's pretty startling. It's pretty horrifying when you see a burning squirrel or a rabbit on fire, running for its life, running into a pile of wood next to your house, trying to save itself, okay? Think about that. That's a wooden fence on fire, guys. Wooden fences are wonderful wicks for carrying fire right to your home. That doesn't mean that you can't have a wooden fence, but certainly the section next to your home would be much better served by being a stucco wall with a metallic or non-organic gate, okay? Because that's what goes right into the side of your garage and under your eaves and can light up your eaves and into the joists, and then you're off to the races. Also, please remove piles of wood and debris from around your house. Please resist the urge to stack that cord of firewood next to the house where you can get at it easy, because that could be the thing that takes it out. Also, wooden sheds. Do not put wooden sheds under the eaves or next to the house, okay? Also in zone 1, you want to have a lot of hardscape. This is sort of a southwestern style befitting the structure, but what's nice is that the plantings are hydrated, well spaced out, and we've got rock mulch, which is appropriate for a southwestern style native landscape. Don't plant under the eaves. I can't emphasize this enough. This is actually the very first of many actual case histories that I'll show you. This is one of our clients in Ramona, and the house didn't burn, but this was an incredibly hot fire. If you look at the lawn there, the grass actually burned. And if you look on that hill in the background, that silver streak is actually a molten water tower. That's how hot this fire was. But all the way around the house, we had this apron, this concrete apron, and also the shade structure is metal, not wood. And so even though this was a very hot fire that burned down both neighbors, our client survived. And aprons are incredibly important to this concept. This right here is actually another project of ours. This was actually our very first fire-resistant design landscape. We put it in about 1999 or 2000. And we actually built a little gravel apron that we put all the way around it. It's about 3 foot wide. Nowadays, I just run the gravel right out to the pathway, but this was our first attempt here. And it made it through the 2003 cedar fire. This was actually taken very recently, and the landscape's doing just fine. And you know, all our native plantings are lightly irrigated. So we're going to talk about the importance of that in a minute. That home, by the way, was part of our Navy study. Also in this zone 1 array, right around the house, is where you might have, you know, permanently irrigated plantings. In this case, we have a lawn, but it's not a grass lawn. It's actually a native substitute called Carex progressilis. And being in La Jolla, I thought we were going to have this nice mown lawn to take a picture of, but they just like the way it looked. They like the natural hummocky look of it, and I kind of do too. So we were a little pleasantly surprised by it. But you can mow it. Even smells like grass, and it only takes about half the water of a standard sort of fescue lawn. Now let's talk about this second zone, outwards of zone 1 or A. This is zone 2 or B. And it can go out 150 feet or more from the house, okay? Especially if you live on a slope. Site hygiene in this area is critical. Now, in this second zone, people tend to either have native vegetation or they've landscaped it. Either way, site hygiene is critical. What do I mean by site hygiene? I mean no weeds. Weeds are the flashy fuels that ignite native vegetation. And this house has been through a number of fires. It's doing just fine. And you might notice the oak tree. That's actually an endangered Engelmann oak tree. And the reason that it has kind of a yellowish color is because it's covered in bright yellow blossoms. And the reason it is so happy and covered in blossoms is because we removed all the competing weeds from around it. Every one of the 40 mature Engelmann oaks on this property went into bright yellow bloom. None of the surrounding properties did. I mean, you could have seen it from a satellite. And of course, if you have flowering oak trees, that leads to acorns. And if you have acorns, that leads to more oak trees, or squirrels, I guess. But there are whole conventions. Why aren't the oaks of California reproducing themselves? If I ever get invited to one of these things, it's going to be a very short talk. So this is what we're talking about. This is what the before was, where that oak tree was. I mean, the only thing native in this whole photo is that oak tree in the center right there. Everything in the foreground and on those surrounding hills and pepper trees there is non-native, as you know. But again, this is what people's concept of native landscapes is. And this stuff is incredibly flammable and ready to burn every year and has a very, very negative impact on our soil ecology and survival. And it does help increase fire frequency. And here's an example of a site that had good site hygiene that went through the cedar fire. You don't have these up there. This is what we call a mission manzanita, Xylococcus bicolor. And it is happy as all get up despite having been through the cedar fire. This homeowner had removed all the non-native weeds. The only thing that smoldered during the cedar fire was the compacted duff layer, the natural duff layer. But the plant itself was nicely hydrated. It didn't even scorch. The leaves didn't even scorch. In fact, you wouldn't even realize that a fire came through here except for the ash on the ground and the dead knotwood that burned out. But the plant itself, to this day, is as happy as can be. Site hygiene is everything. Yes.
So there are a couple questions coming up in chat about what you mean by hygiene.
Yes.
So some of it is questioning. One of them says, I'm curious when Greg says no weeds, does he mean dead weeds or green ones? And then there were some questions also about the leaves on the ground.
So that's a good question. So by weeds, I mean all weeds. Whether they're living or dead, and hopefully they're removed while they're living so they don't, you know, desiccate and become a real fire hazard. Weeds and native plants are an ecological switch. They do not coexist well together. Unfortunately, it's usually the weeds that win because our ecology, while being resilient in the face of heat and drought, is not at all resilient to disturbance, water, fertility, or weeds. And weeds are a very different kind of ecology. Our natives, as you might know, are based on mycorrhizal fungi in the soil. Weeds often either are opportunistically mycorrhizal or bacterial based, okay? And so, and weeds like mustard actually secrete cyanide compounds into the soil to destroy the mycorrhizal soil fungi. So they will knock out the native plant community and take over. And that's why you'll see fields of mustard and nothing else, because they literally have searched and destroyed. On the other hand,
can you give some advice also on how to get rid of weeds when you get to that point?
Yeah, I will. On the other hand, Chaparral itself has its own natural weed inhibition. When it's healthy and at about 70 to 80% canopy closure, healthy chaparral is clean as a whistle. The indigenous folks could walk 200 miles barefoot through it. You wouldn't go 200 feet barefoot through your typical open field in a suburban location. And yeah, getting rid of weeds, you know, it's so controversial. You know, there's a lot of different strategies. I think I have a section later that we can get into it. Oh, and on leaves, leaving leaves, this comes up a lot, and especially with regard to oak trees. And my position is that removing the natural leaf litter that forms around oak trees creates more of a risk than leaving it in place, because by removing it, you end up with an oak tree that is dehydrated, whose ecology is being heavily compromised by the weeds that take over, and is surrounded by non-native flashy fuels that can create a fire ladder into the canopy. Much better to leave the natural oak leaf litter in place to keep it hydrated, keep it healthy, keep it weed-free. So that's the position on that. In fact, talking about canopies, it's really important to prune up large shrubs and trees to about 3 times the understory height. You want to have clearance of about 3 times the height. So if you have, say 18 inches of vegetation, understory vegetation, you want to prune that tree up to about 6 feet. You know, you're 3 times the 1.5 is 4.5 feet, plus the height of the vegetation is 1.5 feet, equaling 6 feet to the lower branches of your large shrubs and trees. That's what really helps mitigate the potential fire ladder for the fire to actually ignite the understory and then ladder up into the canopy and ignite the crown. One other thing is, when we have native chaparral on our site, we do not use the word clear. Clear is anathema. And if for any of you folks dealing with the media, do not use the term clear. We prefer thinning. And thinning by about 50%, give or take, is our typical, that's the typical prescription. We're looking at it, it may not even have to be quite to 50%. 40% clear thinning may actually be appropriate. But this is what that looks like. That's the before picture, and that's the after picture, okay? And one thing, when you're thinning the chaparral, don't just discard all that debris. Chip it up and put it back down on the site. It's the best mulch there is. It's actually what we tried to emulate with gorilla hair, with our shredded redwood bark. And it helps when you've opened up the chaparral canopy, it helps discourage weeds and keep the moisture in. So we will usually, the stuff is like gold, and we usually grind it up and put it right back down on the site. And by removing 50% of the coverage, you're actually removing about 70% of the fuel volume. Yes, you're creating a mulch layer that typically has a pretty low flame height, but you're trading that for hydration. You're keeping it hydrated, healthy, and you're discouraging ladder fuels in the form of flashy weeds. And then you can really have fun with it. I mean, people don't realize what an asset they have if they've got, chaparral or plant communities at the site. Prune it up, open it up, carve out a mature native landscape. Run pathways through it that double as little fire breaks and give access. Put benches out there, bridges, bird baths. I mean, it's amazing. You can carve out your own private native park, your own private preserve from what was once impenetrable fire-prone chaparral, okay? I really want to get through to people that have beautiful properties that destroy it all and replace it with something that's actually much worse than if they had just cleaned up and performed hygiene and maintenance on what they already had in a mature landscape. That's what that looks like. I mean, this again went through the cedar fire. This property survived in 2003. Beautiful manzanitas in East County, San Diego, and cleaned up. It's very accessible. It's nicely opened up. The grindings are used as a mulch that help discourage weeds. They get wildflowers coming up through here. And again, they describe it as their own private park, all right? And every fire service, Dr. John Keeley, when he observed this site, they were all impressed. And again, it's been through actual fire and done very well. So this is what we recommend you do with mature stands of chaparral. What do we target? Yeah, we will target chamise, and we don't rip it out of the ground. So chamise and artemisia will typically cut down to the ground but leave the root system. So we still have the ecology, we don't disturb it, and we still have the fungi and the erosion control. But especially the evergreen shrubs, we will retain those and prune them up and put in pathways and access. Now, some of you don't have mature chaparral or oak woodland on your property, so the second zone might be planted. And we prefer to plant with native plants. That's really all we ever use. And what we do in those areas is we do lightly irrigate. And we've found, especially in Southern California, where it gets quite hot and we get so little rain, that the closer we emulate the natural ecology, in this case, i.e. rainfall, okay, the better our landscapes do. And when they came out with MP rotators 20 some years ago, it was like manna from heaven, because they put about 0.39 inches of equivalent rainfall down an hour, just like a gentle rainstorm. So all of our landscapes are watered overhead, unless it's like a little narrow planter, and even in those cases, we'll try to use microsprays. We really do try to avoid drip in most cases, because we've had problems with a sort of localized hypersaturation that doesn't wet the leaves nor wet the mulch, and also it doesn't hydrate the plants as well as the overhead watering. So we give them what they grew up with, rainfall, and that's it. In all of our practices, it's all the same goal, trying to emulate the natural California native ecology as closely as we can, and not introduce anything to these impossibly complex, poorly understood systems of interdependent variables that can cause it to go cascading off in some weird anomalous direction. It's basic chaos theory. So don't introduce anything that we know doesn't exist in the natural condition. And we're even experimenting with doing light hydration on natural plants. This is natural coastal sage scrub that was not planted, that came up to the property line, and to create defensible space, we lightly irrigated to see what happens. And by light irrigation, I'm talking the equivalent of maybe 3/4 of an inch per month in summer. And I can tell you these plants are unbelievably happy. I mean, look at the difference in hydration levels right there. It's very dramatic. And when you're hydrated like that, it really brings the fire resistance up noticeably. Hydrated plants don't burn nearly as fast nor as hot as desiccated plants. And we've shown this time and time again, and our study actually proved this scientifically. So in that zone 2, so in this case, in this home, the first zone 1 was about 30 feet, and we actually built well, we didn't build it, the homeowner built a rock wall around it, and within that rock wall, close to the house, was a well-irrigated landscape, and lots of flagstone. There's a couple of sycamore trees in there too. Also notice the roof on the house is metallic. Then outside of that, as we start to get into zone 2, we put in lightly irrigated native ground covers. You're looking at Backer's pigeon point and some low-growing manzanitas. And then we built a road all the way around the house. Now, at first, the homeowner was horrified to see us building a 12-foot wide road around his house, but later grew to love his country lane, realizing that what we had created was a fire break and a defensible space. And they could certainly light backfires along the outside perimeter if they had to, except that this property is maintained in such a weed-free condition that it really doesn't become a factor. Here's the landscape continuing around the house. We also built an 8 to 12 foot wide decomposed granite apron all the way around the house. And the native plantings are lightly irrigated, well spaced, and lower growing. So I will tell you that this house has now been through 4 wildland fires and is still standing, and so is the landscape. And again, note the metallic roof on there. People ask me, is there a native plant you could plant like on the eaves there or on an arbor, actually we find that wild grape does quite well in fires. It maintains hydration very nicely, and Rogers Red is a really, really beautiful example of that. You don't want a lot of debris to build up. You want to maintain it. You want to clean out, dead branches and that. But, if you want to create, some kind of a bower around the structure, you could do worse than wild grape. So let's talk about the ecologically sustainable fire risk reduction study that we did for the US Navy. And so the problem is that most approaches to creating defensible space are anecdotal and not based on any kind of experimental design. It's kind of what we always did, right? Or this is what they recommend doing, so we did it. But a lot of times these approaches are highly destructive to the environment, and the outcomes can be inconsistent at best. So the US Navy actually had come around to a couple of my presentations on fire-resistant landscapes, and were incredibly intrigued. And why? Well, people ask, why is the Navy interested? Well, they're not just out in the middle of the ocean. The US Navy administers thousands of acres of naval housing, which is located on naval bases, which are usually surrounded by wildland urban interface, WUIs. So they awarded us this research grant, and I was the co-principal investigator with Dr. John Keeley. John is based with the US Geological Service out of Three Rivers, and I've known him for years, and he's one of the foremost fire ecologists in the world. And we set up an experimental investigation, and our goals were to develop science-based fuel management strategies that were ecologically sustainable, i.e. supporting natural habitat, that were lower water and lower maintenance requirement, were aesthetically pleasing, and then we would collect the data from these sites and we would enter them into a very, very sophisticated, very new modeling software program called Fuel and Fire Tools. We use modeling software because people are kind of loath to allow you to light fires on their properties. All right, so here's the selection criteria. The homes had to be located at the wildland urban interface and survive a major fire event, and also include a lightly irrigated native landscape, native chaparral or coastal sage scrub that is thinned according to common prescriptions, and a control area of natural shrubland vegetation. So all the several properties that we used for the study all had these conditions, and all of them went through either the Cedar or the Harris or the Witch Creek fires. And here's our test results. I should actually, before I get into this, I'll describe how we set up each of these sites. So each of the sites was set up with its own weather station and soil moisture device and temperature gauges. And so we could read all of our relative humidity, our soil temperature, our atmospheric temperature, our soil moisture throughout the year. And we would go out and we would collect all this data, download the data every 2 weeks, and then we would take leaves off the target vegetation, which in this case were buckwheats, big berry manzanita, laurel sumac, and scrub oak. And all of these existed in all these three conditions. We would take the leaves back to our little lab that we set up, and we would dehydrate and measure the relative moisture content of the leaves. And that would lead into data about susceptibility to burning. And of course, you had fluctuations throughout the year. This is going from August of 2015 through March of 2018. So, in the winter, spring months, you had higher relative levels of moisture in the leaves, and then that would dip down in summer months and go back up and down and up and down. This was pretty much shared amongst all vegetation types. But what's interesting, and this is an Eriogonum fasciculatum, you'll notice that the levels of moisture were higher for the irrigated samples, kind of as you would expect during the summer months, followed by the dashed line, which is the thin vegetation, and the control, the untreated fuel, had the lowest levels of moisture content during the summer months. And here you can see for Eriogonum, you can see that the irrigated had the highest levels of live fuel moisture content, thinned were the next, and the untreated were the lowest, okay? So this is significant. Dr. John Keeley said that this study actually exceeded his expectations and his ability to make conclusions about the use of native vegetation that was lightly hydrated and creating defensible space, and also thinning as a fuel treatment. Same thing with manzanita, same thing with laurel sumac. In fact, its levels of moisture were very high. It could hold a lot of moisture, 130, 140%. And you say, well, how do you go above 100%? Well, that's relative to the mass of the leaf itself. So the leaf was a certain mass, and the water content was even more weight contained within that leaf, okay? All very consistent. Scrub oak was a little weird. Actually, the thin scrub oak contained a little bit more moisture than the irrigated. It wasn't a huge difference, but it clearly was a difference, but in both cases, they had much more fuel moisture than the untreated samples. It might be because of the leaf size. It might be because of how mycorrhizal these plants are. It might be because of the mulch retaining more moisture, but very interesting. But still, even these are not that far off, and much more live fuel moisture content than the untreated natural occurring plants. So, and this carried through consistently. The dry months, your fuel moisture would be better. Actually, again, the Quercus berberittifolia was a little weird. It kind of reflected there, but the rest of them during the dry months, the live fuel moisture retained was much higher in the irrigated samples and in the thin samples. So what you're looking at is not only, well, there are consequences for live moisture content. For flame length, okay, in buckwheats, the flame length was actually lower in the thin buckwheat, next irrigated, and then the untreated were the highest flame lengths. Same thing here with irrigated, followed by the thin, followed by the untreated. And we think this is because the thin were widely spaced out, and so flames weren't licking and jumping from shrub to shrub as much, and we think that's why the flame length may have been less. Very consistent throughout results, and of course the oak was a little different, with the irrigated having the lowest flame length, followed by the thin, followed by the untreated.
Greg, can you talk a little bit to clarify what flame length means?
Flame length is measured in meters, and it's the average length of the flames above the vegetation when it's burning, okay? And so with buckwheat, you may get 3 meters of flame length for an irrigated sample, less than 2 meters for a thin sample, and 4 or higher for an untreated sample. For melasma, the laurel sumac, again, maybe 2 meters of flame length for irrigated, less than 1 for the thin samples, and 2 and above for the untreated. So flame length can have some consequence as to how quickly fires move. But it's interesting, you'll see as I go on here that it didn't have as much of an effect as we thought it would. Because here's the rate of fire spread. So the rate of fire spread was in meters per minute. And for the buckwheat sites, the irrigated was lower than the thin, which was typically lower than the untreated samples. Same with the laurel sumac, the irrigated rate of fire spread was less than the thin, which was less than the untreated. What's interesting is that in the rate of fire spread, you actually could have less in the thin than some of the irrigated, but both were less than the untreated. And the Quercus site, the irrigated, had a very slow rate of fire spread, followed by the thin. For the untreated, again, kind of an outlier. Untreated was not that bad. So we actually think that Quercus can actually maintain a lot of its own live fuel moisture content because of the nature of the plant and the fact that it has such an extensive root system, mycorrhizal accompaniment, and mulch. But these graphs here are very interesting because then we looked at the rate of fire spread as a function of slope and a function of wind speed, okay? And the results actually graphed out very consistently. The irrigated had the slowest rate of fire spread and changed very little with slope percent, then followed by the thin, followed by the untreated. And that carried through, same on the Chaparral site, almost independent of slope. And again, irrigated had the slowest rate, followed by the thin, followed by the untreated. And then when you look at it as a function of wind speed, again, irrigated had the lowest rate of fire spread. They all went up with increased wind. These are wind-driven fires after all, so you know. But again, the irrigated had the best behavior, followed by the thin, followed by the untreated. These are Eriogonum sites, and these are Chaparral. This is general mixed Chaparral. This is specifically for buckwheat. So the results were published in the Bulletin of the Southern California Academy of Sciences, volume 119. That was last May 20th. And it was called Protecting the Wildland Urban Interface in California, Green Belts versus Thinning for Wildfire Threats to Homes. And the conclusions included, probably most importantly, that the rate of fire spread is lowest for lightly irrigated native plantings, followed by thin natural vegetation as compared to untreated controls. These benefits were apparent regardless of slope angle or wind speed. Native plants, now this is a real important concept here, guys, and why we like to use natives in these fire zones as opposed to standard vegetation. Native plants maintain much higher live fuel moisture content than traditional plants on less water. And evergreen natives exhibited the highest live fuel moisture content. The bottom line here is that it's all about hydration. It's not about plant lists. It's all about the relative hydration of plants. And the bottom line is that it takes so little water to actually hydrate a drought-tolerant native plant. If you take it a step down, lower growing natives, they exhibit even better fire behavior. Ground covers like Yankee Point and Backer's Pigeon Point and John Dorley Manzanita. And of course, you have these added benefits: excellent natural habitat, erosion control, low water use, ease of maintenance, and visual appeal. So, yes, I can't emphasize this enough. Hydration takes precedence over plant lists. Everybody wants me to give them a plant list of fire-safe native plants. It doesn't work that way. Some of the plants that we consider to be the worst fire bombs, like buckwheat, actually benefit the most by light hydration. Here's just kind of a fun example, very unscientific, that we did one year. It was sort of about 30%, it wasn't a Santa Ana, but it was dry, 30% relative humidity. The week before, we'd gotten about a 1/4 inch of equivalent precipitation. And so we just went around and started grabbing samples of chaparral plant and tried to light them on fire. Well, you can see we weren't very successful. That's ceanothus, sugar bush. Couldn't even get the sage to sustain any flames. Even put them together in a pile and tried to burn that, and that wouldn't go. Okay, and that's a propane torch there, guys. But this is what happens when you add the non-native, dry, desiccated, flashy fuels. And this is what ladders up into our native vegetation. In fact, the worst situation you can have is a mix of native vegetation and weeds, because the natives are going to be poorly hydrated. They're going to be unhealthy because the weeds are knocking out the ecology. They're stealing moisture, and they're acting as ladder fuels. And since hydration is the key, there's nothing hydrated about this patch of weeds that we threw in just in our little unscientific test. But you can imagine when firemen are lighting backfires with their oil lamps, they're not trying to light up chaparral. Chaparral is typically very difficult to ignite. They ignite the weeds and grasses, and then that takes it up into the chaparral. So you can look at different types of planting for fire-resistant slopes. I mean, nothing at all is usually a bad option. Ice plant, everybody loves ice plant. You can look at drought-tolerant non-natives and succulents. You can have natives, and all have advantages and disadvantages. So let's look at ice plant. What are the advantages of ice plant? Cheap and readily available. Quick fill. It's green. Disadvantages: poor to moderate erosion control. This stuff is lousy erosion control. I've seen plenty of eroded hillsides with a carpet of ice plant growing on top of the pile at the base. To maintain a level of hydration similar to natives, they need lots of water. They're invasive. They can form thatches that burn. This is so critical. You can form this flammable thatch a foot deep underneath all this green ice plant, and boy, does this stuff burn. I mean, it boils off any water in the ice plant, and that burns too, but the thatch is what starts it. And of course, it can be boring to downright ugly. Now let's look at non-native drought tolerance and succulents. Certainly, they might actually have better availability than many natives, although we're trying to do something about that, aren't we? There's lots of beautiful plants that can be very colorful. The disadvantage is they need about twice the water that natives do to achieve a level of fire-resistant hydration. Certainly, they're better slope stabilizers than ice plant, but not nearly as good as mycorrhizal natives. And they are higher maintenance than most natives because they require more deadheading. When these things are done blooming, you need to cut them back to keep them looking good. Also, they just don't have the wildlife value of the plants that are wildlife actually evolved with. So let's look at natives. And this was a site in Carlsbad, at Aviara. I think Sin might be familiar with that. That was a common area that these oaks were actually deeded in on. They had to protect these oak trees, and when we arrived, they were dying. Leaves were dying, bare branches, they were sick, they wouldn't last another year or two. And the whole thing was planted in red apple and Japanese honeysuckle. So we got rid of all that crap and we put the appropriate plants back in place. And that community loves their native slopes to this day, and it's about 3 acres. What are the advantages? Well, they certainly require a lot less water to achieve fire resistance than the stuff we ripped out of there. The soil biology is naturally soil stabilizing, meaning that it has mycorrhizal fungi, which expands the root systems by about 1,000 times and helps cement and stabilize soil. The evergreen natives are virtually no maintenance. No fertilizer or soil amendments are used. That's one of the worst things you can do with native plants we found is, well, you want to convert it from a clean fungal-based ecology to bacteria. Just add fertilizer and soil amendments. Great bird and butterfly habitat and lend a sense of regional identity, okay? These oak trees, which were dying, are now pushing out 3 feet of growth a year. Look how happy they are. They're absolutely ecstatic. Beautiful. And we mentioned the natural weed resistance that develops at about 70% canopy coverage. Disadvantages, there aren't as many suppliers, and they don't like ornamental horticulture, and they tend not to like drip irrigation long term. Short term, they love it. Long term, they start to, the landscapes start to get unstable. So let's talk about mycorrhizae. I've mentioned it. You won't be tested on, don't worry, but this is endomycorrhizae, which forms little clusters inside the root cells. Ectomycorrhizae forms a sheath around the outside of the root hairs and forms nets around the roots. Regardless, there is a transfer of moisture and minerals and carbohydrates that are occurring either intracellular or through the cell membrane in the case of ectomycorrhizae. The mycorrhizae pull nutrients out of inorganic soil and rocks. They store water. They move that water and nutrition around to where it's needed in the plant community. They give it to the native plants as needed, and in return, the native plants provide 20% of their carbohydrate productions to the fungi. The fungi can't make their own sugars. They don't have chlorophyll. They get it from the plants. This is a relationship that goes back hundreds of millions of years and enables our native plants to survive in pretty stressful conditions. One of the big mistakes that's made when designing native plants is people really love the flowering herbaceous perennials, but they don't put enough backbone into it. You need to use about 75% evergreen plants that have foliar color and texture, like these manzanitas and ceanothus and baccharis and buckwheats here, that the foliage carries it throughout the year. You know, it doesn't look like tumbleweeds in fall. And that's important. These are the plants that are probably the most fire resistant if I had to group them. And then the other 25% are your specimen plants and your perennials that go along the edges. The Margarita bops, right? Vigeiras, erigerons, the seaside daisies. All that color goes right up front where you can see it, and more importantly, you can get at it and deadhead it really easily. And we mix up perennials that bloom at different times of the year, like this silver carpet that'll bloom summer, fall, and these guys that are blooming right now in spring and summer. So that's how you have year-round color and easy maintenance and a backbone to your native landscapes. This is how we like to do irrigation. I like overhead. This is a 12-inch pop-up with a 40 PSI pressure regulator built in. This is a swing joint going into the PVC, which gives us adjustability, almost like a universal joint, and allows separation of any forces that the body might see, i.e. kicking, from the PVC, protects it completely. And on top of those, we put our MP rotators, which are just like rainfall. And, you know, natives do better with more ecological type approaches. And if you have a drip system already, it's very easy to convert to microsprays. Very cheap too. And it's also important for foliar hydration. When planting, we lay things out. We like to use 1 to 5 gallon plants first off. That's usually how they're sold. You know how fast they grow, especially when they're babies. And we space them out for final size. Yeah, you mulch it, and my clients are always going, Rubin, you sold me sticks, or Rubin, it looks like little green tufts in a sea of mulch. And I said, well, I'm here to hold your hand. Call me in 3 months. That's our favorite mulch right there, shredded redwood bark. Much more available up north there than it used to be down here in San Diego, but we were the first to use it on a regular basis. We probably use close to 2,000 to 3,000 cubic yards a year. It sticks to steep slopes. It lasts a long time. It emulates the natural duff layer that forms, probably the best of any material. And it's fire resistant when you consolidate it. It has to be consolidated. I can't stress this enough. You have to water it down and get it down to from 3 to 4 inches thick down to 1 inch. Anything that's oxygenated will burn, including steel wool, okay? And leave your oak litter in place, as I mentioned. And I actually have pictures of how this redwood mulch performed in actual fires. People are so down on it and so afraid of it, but I can show you. I'll show you the actual pictures, okay? And that's how quickly this landscape grows, because we went from basically that to that in 14 months, okay? So, okay, so here's how that mulch performed the cedar fire. Now, of course, you can see what my mistake was here. Unfortunately, I did run the mulch right up to the house. That was the last time I ever did that in a wildland installation. However, my folly actually turned out to be very, very informational, because if you look, you can actually see the flame height by the scorch marks on the screed line around the house, 2 inches or less. And more importantly, you can see areas of unburned mulch, red patches that weren't burned, and even more importantly, those plastic marker flags. Those were put in prior to the fire. In fact, the only one that's melted there melted because of the burning garden hose, not because of the mulch, all right? And this was like a perfect little experimental setup, even though it was completely serendipitous. Now, when we plant, this is a little complicated. We do it a little different than most people, but if you hang in there with me, when we plant native plants, we dig a hole and stick them in, okay? Don't amend or fertilize in most cases. You know, I don't care how poor you think the soil is. We try to use natives that sort of match the site and the natural soil conditions. And there's a ton of natives that grow in full-on mucky clay, believe me, tons, including ceanothus and manzanitas. I do like to make the hole a little shallow, and that's for settling later on. And then I'll backfill with soil, tamp our feet, create a temporary basin, which you will break down when they start to get established. And it's actually crucial that you create basins on slope plantings to get them started. You just can't retain enough moisture around the new plant. If I have 6 to 12 inch boulders, we'll put those right on the root ball. I'm not talking a campfire ring, I mean right on the roots, and just leave a little space for the plant to grow through. And if the plant gets bigger than that, it'll just push the boulders out of the way, no problem. And then the most important sequence is water, water, water. I mean, 1 to 5 gallons in clay soil, 5 to 30 gallons in well-draining soil per 1 gallon plant that day. It is tedious, it is boring, it is the most important watering these plants will ever get. And you often will have to circle through the planting several times to infuse that much water. But what we're trying to do is remove air pockets and settle the soil around the root ball. Very important, okay? And the best way to do it is water, water, water. We might put down something called a pre-emergent at this point, which kills seed in the soil, because you can have a huge number of seeds, dormant seeds in the soil. And it won't harm the growing plants, it just kills seed. And then we'll put down the mulch. All right, now I'm going to really mess with your paradigms, because we have to talk about what we've discovered to be probably the worst pest in our landscapes here in Southern California, and they are all the way up into Washington State and going farther. And what you're looking at is the root and lower crown of a dead ceanothus. And what appears to be rough bark is actually scale. That is scale covering that root crown and root, and the plant was so dehydrated it actually cracked all the way to the middle. But that scale, which below ground is sucking all the moisture out and the sugars, doesn't get there by accident. It gets there by Argentine ants. Turns out that Argentine ants may be the very worst cause of mortality in California native landscapes, and probably the single largest cause of death. And the problem is that they actually nest in the root ball, and they remove soil from the root mass. And what that does is it destabilizes the plant. A lot of times when these plants fail, you might notice that they're kind of loose in the soil. You can rock them back and forth. Like the soil sort of pulverized. And then they protect and place these sucking insects, scale and aphids, all over the roots. So they start killing the plant from below. While they're doing this, they also plant weeds like crazy, and also maybe directly inoculating diseases from sick plants into the roots of healthy plants. They plant weeds because they eat the attachment point of the seeds, not the seed itself. And so when they drop the seed, it germinates, usually right outside their nest, which explains why you'll sometimes see weeds growing out of the base, the crown, of an otherwise densely foliated plant and nowhere else. It's because the ants planted those weeds right at the base, and when they kill the main plant, they can move over to the weeds and keep the colony going. And they do this all along their trails. They do this in the crown of the plants, and virtually all the plants that are considered to be short-lived or difficult are being killed by ants, like ceanothus, like all the mallows. They love mallows, marshmallow, including flannel bush, which is now reclassified as a mallow. Every one of the flannel bushes that has died on our watch that we've checked in the last 10 years had an ant colony in the roots, and they were being killed, and then they finally get diseased from whatever plants they're infesting around there, and they're bringing in Phytophthora, they're bringing in Fusarium, they're bringing in Verticillium, they're just bringing in all kinds of nasty stuff. They're bringing in that greening disease of citrus, they're moving Asian citrus. It's not just about natives. They're moving Asian citrus psyllid around in agriculture. Okay. What's interesting is in these areas, in these sites where we're getting the ants under control, we're getting miraculous recovery in the plants. We're bringing completely dead ceanothus back. They're stump sprouting like a fire came through there. Flannel bush coming back to life. Manzanitas coming back to life, okay? Because we took the pressure of the appropriation of the moisture and sugars. I also use some neem oil to help with the diseases, and then I stimulate the roots with Super Thrive. So you can control the colonies themselves with slow-acting baits, but we use a combination of a pyrethroid, neem oil, and Super Thrive as a root soak to save a collapsing plant. Bait stations are good for long-term overall control, especially if you put a perimeter down of a pyrethroid or something to keep the ants out of your yard because they're a super colony and they just keep moving in. But if I have a dying ceanothus, the only way you're going to save it is to come in there with pyrethroid, neem oil, and Super Thrive. You've got to control the ants, you got to control the disease, you got to stimulate the roots all at once. And the result has been that our plants don't die anymore. Our natives don't die anymore. I don't lose ceanothus. I don't lose manzanitas. I don't lose flannel bush. I don't lose coffee berry. Okay? It's extraordinary. It's been extraordinary. And I'm just trying to get the word out because they're up there, guys. They're up there. You've got Argentine ants, unfortunately. All right, and I'll finish up here with some case histories. And hopefully you don't end up like this guy in Rancho Bernardo. Look at his roof. How would you like to be standing with a water hose on a shake shingle roof with the fire, the flames that close? I think he did survive, though. I think he did live. Okay, so as I mentioned, we've had more fire-involved native landscapes of any contractor in the state. So here are a few examples. We had one in the Pumashaw, we had 2 in the Pines Fire in Julian, 7 in the Cedar Fire, we had 6 in the Witch Creek Fire, we had 2 in the Harris Fire. We even had one in Hidden Meadows where kids lit up the Chaparral lighting fireworks down at the base of a slope, and the fire went up there and stopped in my customer's yard. And we even had a fire marshal from the city of Encinitas test an actual burn test in the gorilla hair. And his comment was, what kind of fire retardant are you using in this stuff? So there's that customer's yard after the cedar fire. They're large unburned areas. All the plants are alive. They just got scorched, but they all came back. The mulch smoldered, but without any flame height. And if you're in that situation, all you need to do is take a rake and rake the fire line into the black and, you know, end of fire spread. And there's the backyard. Large areas of unburned mulch, plastic flags everywhere. Now, that doesn't mean that this house didn't almost burn to the ground. It had nothing to do with the landscape. Back on this corner right here, the wife and husband got into a huge fight about a week before the cedar fire. Thank God she won and had him move a cord of firewood that he had stacked. Oh, crap. Sorry. I hit the wrong button. Okay, where am I? There, are we up again? Yeah, okay. Anyway, cord of firewood was stacked right here. She won the huge argument, so he moved that out over by the propane tank. And then at the back here, they actually had wicker furniture, which had about an 8-foot flame height that the CAL FIRE people saw. They busted down the door, tore out the drywall on the other side, and saved the house. Okay. So that doesn't mean that if you have flammable stuff around your house that your landscape is necessarily going to save it. But what else did this house have going for it? Double paned, metal framed windows. Do not use vinyl frame windows again in the wildlands. They melt and the glass just falls into the house and here come the flames. Boxed in eaves, tile roof in this case. Screened vents to keep embers out, okay? And then of course our defensible space, a lot of hardscape in zone 1. I had some small plantings close to the east here, but they're only about 12 to 18 inches high. And then the mulch was well consolidated. And in case you're wondering if they were really in the cedar fire, well, that's the view out their back window, okay? They were in the middle of the cedar fire in 2003. So all of our houses have survived. Here's one that was in the Witch Creek fire. Remember I was telling you about wild grape? Well, there you go. You wouldn't even tell a fire came through here except for this incinerated Ficus benjamina. And then, of course, I want you to notice the overhead structure, which is masonry and steel, okay? But the wild grapes maintain an incredible level of natural hydration. And this is a great illustration of relative fire resistance on the same level of hydration between native and non-native plants. So the black smudge on the left was a ground cover rosemary. The plant on the right was a buckwheat that blew in on the wind. Well, it still had green leaves on it. This landscape was getting watered about once every 14 days in the summer. That was enough to hydrate the buckwheat and keep it from burning to the ground, but it clearly was not enough to sustain the ground cover rosemary. That ground cover rosemary should have been watered about once a week. So about twice the watering that natives require for the same level of fire resistance. And in this house, you know, again, my mistake is I planted vegetation too close to the house, but notice that there's no scorch marks on the house. So because they were hydrated, the flame height and the radiant heat were much less and didn't even scorch the paint. That's the same house with a apron around it, which we talked about earlier. Okay, on this house, this was getting watered about every 10 to 14 days. Bacchus pigeon point, Rhamnus Eve case, a little bit of Toyon, Archistaphyllus franciscana. Anyway, you can see that it didn't generate enough heat to burn the wooden deck at the back of the house. Now, I did not install that wood deck. I don't know that I would have, but regardless, it survived. There was a few embers that popped in and did a little bit of burn through, but nowhere near enough to ignite the house. And just to show you that this, you can also, by the way, see the irrigation right there. It's one of the irrigation heads. This landscape was fully intact. It was just scorched. And here's the same landscape 3 years later, okay? And I want to talk about this concept of clearing, because people, there are a lot of agencies that are pushing for you to just clear the bare ground around your homes. Well, these homes, these people all cleared 100, 200, 300 feet around their house. This guy did massive environmental devastation. Beautiful chaparral, gone. Well, unfortunately, it didn't help his house, did it? In fact, the lawn and the queen palms are still there. And being an old aerospace engineer, I kind of quickly realized what was going on here. When you remove all vegetation from around a home, thinking that you are creating a fire defensible space, a fire resistant zone, all you're doing is creating laminar flow. Laminar flow is a perfectly smooth surface which can actually accelerate wind And in this case, the wind is near zero humidity, full of embers as thick as the fire falls of Yosemite going sideways, and absolutely nothing to perturb the flow, to cause turbulence, or to catch and cool embers. In fact, the only thing in the way of this flow is your house. And we would see this, I've seen it over and over and over again. People that cleared all the way around their houses. Their house is a pile of rubble, sometimes surrounded by still green palms and lawns, okay? And my friend Rick Halsey would put it, you created the perfect bowling alley for embers, all right? So a lot of the conventional wisdom is just wrong. It's just wrong. And this guy destroyed so much habitat in the process and lost his home, okay? Yeah, the lawns are still green. Fan palms, by the way, were the worst actors down here. Fan palms were the single greatest cause of fire spread in suburban neighborhoods in San Diego during the Great Fire events. And what's worse still, all the fire does is prune them. They come back green and beautiful. They never look so good, okay, laughing at you because they ejected their 4-foot flaming frisbees flying at 40 miles an hour and igniting everything in their path, including cars and homes, getting under garage doors. I hate fan palms, guys. I hate fire too. I am not a fan of fire. I'm not a fan of prescribed burns. I'm not a fan of burning anything. We got enough fire already. We don't need more in this ecosystem. It's screwing it up. We're losing it. So here in the Harris Fire, the Harris Fire actually hit our hydrated landscape, went around both sides, rejoined and continued right up Lawson Peak. And not even the mulch burned because it was hydrated. I mean, guys, it doesn't get any starker than this, okay? Hydrated native landscape, maybe 6 to 10 feet. Untreated chaparral in the background, $75,000 solar array. And so my customer was pretty happy to see not only his solar array, but his house still standing when they came back. I had 2 clients on the street. Both of them called me after the fire and said, Rubin, your landscape saved my house. That is a nice call to get. That is a nice call to get. So when I started giving these presentations and continued success with this, that's what got the Navy's attention, and that's why they decided to fund the study. Lastly, some of you might have a situation like this where you've got severe erosion potential and gullies behind the house. The worst thing you can absolutely do is seed after fires. Don't seed after a fire. What do you do then? You take T-posts and run them across these gullies, maybe depending on the steepness of the gully, every 10 to 15 feet. Take the dead burned branches and weave them in between. You're not trying to stop water, you're trying to stop debris and allow the water to come through. And then around the house, you can do some sandbagging to direct flow into drainage. That's it. This is what happens when you aerial seed. This is actually a photo from many years ago on Cuesta Grade in San Luis Obispo. And you can still see to this day, this is the 1980s, to this day you can still see those bands of non-native vegetation because the chaparral did not return in those areas, okay? And what they seeded were non-native grasses and mustard. The absolute worst thing you could do for the ecology, for erosion control, and for fire. This is what you should do, especially if you're in a wild space. Leave it alone, okay? So here's the dynamic. When a fire comes through a shrubland, burns everything to the ground, very rapidly you start to see stump sprouting. What fuels that stump sprouting is the mycorrhizal grid that has the stored nutrients and water. And that is fueling the rapid recovery of the shrublands. But as this process occurs, it depletes the mycorrhizal grid. So then in fall with the rains, here comes the mycorrhizal wildflowers. And the wildflowers replenish the grid. And then when they're done, they have so little lignin and cellulose in them that they get completely reabsorbed back into the ecology as if they never existed. So what happens when weeds come in there and not wildflowers? The weeds are not mycorrhizal. They don't put anything back to replenish this diminished grid. In fact, they rob from it. And since they are typically so full of cellulose and lignin, when they die, they just remain above ground. All that stolen nutrition and moisture just stays in a thatch above ground, which is then ready to burn again. And in the process, it collapses the native plant community. And that's why weeds and natives are an ecological switch. I hope you guys are following this logic, okay? You don't seed after fires. The worst thing, even if you have so-called wildflower seed, most of it has contaminants in it, and it's the contaminants that win. Star thistle being prime amongst them. This was close. This was in Escondido. Everybody was running to the desert to see the wildflowers that year. Heck, all they had to do was stick around Escondido after the fires and look at it. It was incredible. It was amazing, beautiful. And we knew, and these plant communities came back beautifully because they were replenished. They were replenished by the wildflowers. And so did the landscapes. The landscapes, for the most part, all resprouted and came back after the fires. Yet here's a site that was seeded, okay? No life. The ecology is gone. That oak tree in the background will soon be gone. Just devastation. Nothing good about that. Ready to burn every year. Star thistle. This is the kind of stuff that you walk through and you have to throw away your socks. This is what it should have looked like. Clean. Sometimes you'll see silica glass on the ground. Just leave it alone if you're in a wild area. You know, 1 year later, and then 5 years later, well on the recovery, and that, guys, is the end. Thank you very much. So I hope you got something out of it. I can take questions.
Okay, I do have a few questions for you. I'm
ready.
Okay, I collected some questions. There was quite a bit of chat, but I tried to pull out things that that seemed like something we could address at the end. So one of the first questions I grabbed was, you talked a lot about big acreage out in sort of the wildlands, but there were a lot of questions about how would you address with these issues in suburban landscapes with less acreage. So maybe we're talking about 1/4 acre lots.
Yes, or even smaller.
Or smaller, absolutely.
Right. So there's a couple of things. One thing that I'm trying to stress to agencies is rather than go out and do clearance in the middle of nowhere, concentrate your funding around communities. Create these modified zones that we studied in the Navy study. Create these modified zones in defensible space all the way around our communities. Create lightly irrigated native plantings that serve as a transition from the wild chaparral or oak woodland to the yards, to the neighborhood. And put light irrigation on it, very little, just a fraction of what, you know, your typical honeysuckle red apple requires. They're watering 3 times a week to every day, okay? We're talking once every 7 to 14 days in summer, okay? Plus you've got habitat, plus you have incredible erosion control, plus it looks great, plus you're educating the public, you know? I mean, this is one thing, so that's gonna help defend neighborhoods. The other thing is to educate the public, because people will need to band together at that point to create larger areas of defensible space and fire-resistant plantings. Also in developments, not positioning houses right on the edge of box canyons where no amount of clearance will save a home as the fire goes rolling right up the hillside and nails all the houses at the top. I've seen houses cleared 300 feet. Well, we talked about that. Boom, no defense right at the top of these things, you know, or at the end of a cul-de-sac, at the end of a box canyon. You should be putting a park there. Don't put more houses there, for God's sakes. All right, move the houses back from the edges, you know. Also, I'm trying to counter the misinformation about natives in general. That natives are going to somehow spontaneously burst into flame and burn down your house. Okay, it's really actually the opposite, given a little bit of hydration. And that's why I can't stress enough that it's not about plant lists. It's about live fuel moisture content. And we know how much, we know how to do it. And we've had, we haven't, knock wood, we haven't lost a house yet. Okay, we've had 30 homes almost go through it. So that's kind of how it has to be dealt with. And right now I'm just trying to get the word out to the public. In my first book, The California Native Landscape, we actually have a whole chapter that's devoted just to fire and a lot of these concepts. And right now we're working on a follow-up book that's going to be on maintaining California native landscapes. I'm going to have a whole chapter on ants and probably a whole chapter on treatment of native vegetation for fire resistance. I might even write a whole book about it. I mean, there's a couple of books out there already on fire resistance. They're okay, they're not bad. But one thing they lack, I don't see any pictures of real landscapes that went through fire, So, every time one of these fire events occurs, it's traumatic. It's traumatic for the people. It's even traumatic for me because I'm worrying about my clients. And I'm hoping that things still pan out, that it's going to work, But, I can't guarantee a home won't burn in a firestorm, but we can sure do a hell of a lot better than we're doing now, okay? And get all these other benefits while you're at it.
And will you talk a little bit about mulching? So there was a lot of chat back and forth about using rocks, using organic mulches, and also a question of if you could address something called biochar as a mulch.
Well, okay. What is mulch? It's not an arbitrary material on the ground. What we're trying to emulate here is the natural duff layer that forms in these plant communities. Why? Because we don't have millennia of existence to form its own mulch. We're breaking into that chicken and egg cycle with brand new plants, and we're creating a plant community. So we have to use something, we have to start with something. And we found that for plants, for communities that like organic mulches, okay, and that's not all plant communities, but the ones that love organic mulches really seem to love shredded redwood bark, because the shredded redwood bark is like the closest thing to the natural duff layer that forms and accretes over time, that compacts down. Natural duff layer in Chaparral is usually less than an inch thick, but it's very dense and very, it's almost like carpeting. Well, the redwood does the same thing. And that's another reason to go with overhead watering, because that's a very important part of not only the ecology, but also the fire resistance, by creating a really densely packed, poorly oxygenated fuel. But not all plant communities want organic mulches. Can you guys think of maybe one that doesn't? How about desert? Coastal strand? Grasslands? They don't develop, they don't drop enough debris. They're not leafy and dense enough to create a contiguous mulch layer. So in those landscapes, with those plant communities, and in order to promote the symbiotic development of a plant community, we use sand, rocks, and gravel, just like Mother Nature does. So right there, that should give you an indication of what kind of mulches we're using out there. Now, I like to create an inorganic apron around houses. I don't like to plant under the eaves unless, you know, it's really, really low growing plants. And they, in that case, they need to tolerate an inorganic mulch because I don't want to run the redwood bark up to the house, even though we know the, you know, the scorch marks are less than 2 inches. We just don't want to tempt fate. Also, a good way to cheat with inorganic rocks. It turns out that just about any plant from California in any plant community loves rocks, but not gravel. I'm talking about 6 to 12-inch boulders right on their roots. And that's a good way to cheat because you, as long as you have those boulders on there, a lot of times you can use an inorganic mulch because that's the look you're going for, and you'll be okay, all right? But you need mass. You need mass around those roots. Over time, the chaparral, manzanitas, and that will start to make their own mulch around it, and you leave it. You leave that circle of mulch. You don't scrape it up, okay? Because that's promoting the ectomycorrhizae, the aerocord mycorrhizae, okay? So mulch is inextricably linked to the soil ecology. It's not just a fancy top dressing. It's linked to the biology of the soil, and the mulch drives the plant community, and the plant community drives the mulch, all right? And you can cheat, all right? But in reality, the plants do best when you use the right mulch around them. Ectomycorrhizae, which we talked about a little bit, is the prime fungus of our evergreen woodlands, very prevalent in manzanita and that. And these form a really thick duff layer around them. And the mulch is very shallow. Ectomycorrhizae is right near the surface, and it'll send hyphae right up into the actual mulch layer and can pull micro amounts of nutrition out of it at a very slow rate and give it to the plants. Endomycorrhizae, which is primarily deserts, coastal sage scrub, that kind of thing, is deeper typically, exists in inorganic soils. And so we'll pull it out of mineral soils, and plants like oaks can actually have both. Deeper layers have endomycorrhizae, upper layers have ectomycorrhizae. So these are impossibly complex systems, and I don't even try to figure it all out. All I do is try to create the right boundary conditions, the right mulches, the right type of irrigation, the right plants together, and just let nature do its thing. Just don't introduce anything that I know is foreign to that system. Just try my best, as best I can, to emulate the natural system and go with it. And it's been very successful. Our historic mortality rates in landscapes were around 5% or less. Now it's kind of creeped up to around 10% because of our hotter summers and because of the ant issue. The ants, as it's getting hotter, there's more and more ants, and it's just a nightmare. We're trying to educate the public so they're taken seriously as a pest, so we develop worldwide strategies to deal with them. They are considered #1 invasive pest in the world. Yeah, so.
Wow. Okay, so this is a question that came up when you were talking about clearing the spaces. And the question for Greg, what do we do with the years-long established, in parentheses, overgrown landscaping we see in the Oakland Hills? 40s and 50s landscapes of junipers, acacia, oleander, rosemary, aged pines, etc. So some advice of how to talk to people who have these landscapes.
I know. It's really hard to deal with. I mean, if people don't have that passion, it's really hard to get them interested, except to show them lots of really cool pictures, or have garden tours. You guys have some of the best garden tours around, and get them interested in that so they can see it in the flesh. I mean, you guys live in veritable paradise. You get enough rainfall. Now remember, down where I'm at, we average 9 to 10 inches of rainfall a year, okay? Up there, you're 30, 40, you know. Plus you have tons of fog drip. Plus you have more moderate conditions. Plus you have higher humidity, okay? Leslie's shaking her head no. Not anymore, right? Not anymore. That's all changing now. But I remember when the Oakland Hills burned up. That was not fun. Yeah, I remember that. But it is a little bit more favorable environment. See, the problem is that a lot of the plants that we use down here in San Diego come from up there. You know, Ceanothus Yankee Point, Bacchus Pigeon Point, Arctostaphylos Carmel Sur, sound familiar? I mean, you could take a little ride around the area there and go see the Monterey and that, and go see all these plants growing in their natural habitat. And then we got to make them work down in San Diego. Okay. One of the things I'm pushing our local folks down here is to have more local indigenous species available to us, including local evergreen ground covers, which we need to find. But juniper is a disaster. Eucalyptus is a disaster. Pines need to be maintained and probably should have a lot of spacing in between them, especially next to houses. Very important also to clear the debris off roofs. That's the #1 actor in these suburban fires. That's how it jump, and that's how they catch your house on fire.
Okay, and I have one last question for you, and it's sort of mathematical. I think it kind of came out of left field and people didn't know they were supposed to get the formula down. So I'm going to ask you to go over again how you talked about how to do the canopy clearing on a tree.
Oh, okay. You want a clearance between the low, okay, so maybe you might have a situation where you have a tree or a large shrub, okay, surrounded by low vegetation, okay. The gap between the low vegetation and the bottom branches of whatever tall shrub should be 3 times the height of whatever that low vegetation is.
There we
Does that
go.
make sense?
Yes.
So the math isn't too bad. You just want a gap of 3 times the height of whatever the surrounding vegetation is. If you can maintain it, you know, if it's impractical, just do your best. You know.
Okay, I think that gets to the end of the questions that I was able to pull out of the chat. Actually, I see down here there's new messages. Let me just check here. This manzanita count is understory.
Oh, there's some that's understory. There's ground covers. There's shrubs. There's virtual tree forms. Yeah, and everything in between. Manzanita is one of my primary foundational plants out there, and they're available in so many different colors and textures and flowers and berries and bark, and they're just amazing. I don't think I've ever done a landscape without some manzanita.
Okay, Sue, do you have anything else that you wanted to add into here? Oh, it says, please ask about watering manzanitas in the summer.
So I just give them that light overhead irrigation.
Okay.
And a lot of manzanitas are used to fog drip. They're also much more tolerant. The amount of irrigation that we're putting down in the summer is equivalent to a summer thunderstorm, maybe 2 or 3 times a month, well within the tolerance limits. We even had a summer here in San Diego where in July, we got 7 inches of rain in less than a week. And there was a lot of hand wringing and henny penny, and the chaparral was going to die. Guys, the chaparral never looked so good. Okay, it has a much wider tolerance of moisture and different moisture regimes than we can even imagine. And the problem is pathogens and pests, especially when those pests are bringing in the pathogens and depositing them on the roots.
Right, Sue, I'm going to pull you back in. I think we're probably running towards the end of our clock time here. Thank you very much, Greg. I appreciate the conversation with you.
Well, it's my pleasure. I hope you guys enjoyed it and got something out of it. And I really appreciate your attendance and your interest.
Had a great group. Sue, are you there? Oh, I don't know if she's going to make it back on. Sue?
I see her.
Oh, here we go. Oh, please unmute yourself, Sue.
I am muted and I found the second slide, so I was trying to put that up there. I was able to make it advance. So let me put up that second slide here and then we will all say goodbye once I get it up. All right.
You know, and if you wanted to even unmute everybody just so they could, you know, if they have any last minute questions or whatever before we, you know, whatever you guys moderating, whatever you want to do.
We can do that. I am not sleepy, so yeah, I will. Let me take this down, then I'll just stop sharing. And all right, if people would like to unmute, I will make it possible for you to do that here. Okay, if anybody wants to unmute, you should be able to do that now to ask an individual question.
Greg,
thank
somebody
you.
was asking about watering. Delia? There was a question from Delia, and then I'll take the next question. How often to water? So all MP rotators put down 0.39 inches of equivalent precipitation an hour. So I'm typically putting down 0.75 to 1 inch a month in the summer months. So that usually equates to about 2 to 3 times a month for 30 to 40 minutes with an MP rotator system.
I have a question about Baccharis. A lot of the fire departments up in Northern California don't like Baccharis, presumably because of the oils in the leaves. So are you saying that if it's low enough and hydrated enough, it shouldn't be an issue? Because it would be a really useful plant.
I'm surprised to hear that because Baccharis Pigeon Point and Twin Peaks are on most fire department safe lists. They actually think of it as being a pretty fire resistant plant. Now for me, again, it's all about hydration, but that's an easy plant to hydrate. So I'm not, maybe it's the shrub Baccharis, the straight, you know, consanguinea or pilaris consanguinea that they don't like because it can get pretty woody and have a lot of fine material. But boy, I'd be surprised if the dwarf coyote brushes are in the same category because they are great for these fire resistant landscapes. And it's on most fire safe lists that I see.
Okay, thank you.
Mm-hmm.
It's also an important food source for some of the butterflies.
Oh yeah, they're the pillar of their communities. You see the weirdest, coolest bugs you've never seen before in your life on Baccharis. Yeah. And buckwheat.
Yeah.
Okay, so I think, have we come to the end of the questions?
I had a question that was also echoed by a couple others in the chat, which is, Greg, just curious about when you have spaces, you're talking like acreage, in terms of like, you know, multiple acres. How are you doing non-native weed control? Because sheet mulching has been mentioned in the comments, but a lot of us are envisioning that that's not practical at that scale. So if you could talk a little bit about that.
Well, let's see. One very effective solution, you're going to laugh, is very low density cattle grazing. Cattle grazing at very low density. I'm talking maybe 1 head per acre. Can actually be very effective, especially with cross fencing. You can't pull your way out of this one. You got, if you're not using a biocontrol like cattle, because that's really what it is, biocontrol for a lot of these weeds, you got to get into herbicides. And you know, I've tried them all. You know, we do judiciously and responsibly use Roundup. People usually start throwing things at me right now, but honestly, there's been so much energy put into glyphosate because it's Monsanto. And Monsanto are not my favorite people either. And by the way, it's Bayer now. Bayer has bought Monsanto. Monsanto is now a division of Bayer aspirin, one of the largest chemical companies in the world. And the reason we liked glyphosate when it came out was because it was biodegradable. And yet nobody's saying anything about triclopyr, 2,4-D, dicamba. There's some really nasty herbicides out there that stay residual in the soil, that get moved through mycorrhizae. All you that have lawns and have used weed and feed, you just loaded your lawn up with triclopyr or with 2,4-D, and then gets watered into our drainage systems and out to the ocean. Nobody's saying anything. It's an active ingredient in Agent Orange, you know. So I've got this tool, glyphosate, that I don't crop dust with. That's what they're doing. These agri-farms or agribusiness is crop dusting with and killing everything except the Roundup Ready GMO crops, right? That's a problem. We use it very minimally and responsibly, and we wouldn't be able to do a lot of the ecological restoration we do without it. There's just no economical way. There's not enough labor in the world to sit here, plus all the disturbance that takes place, to go in there and somehow hand remove stuff. But cows are a good start. Horses are the next best, but they can eat bunch grasses. Llamas eat everything good. Sheep eat everything, and goats eat anything. So I've tried them all.
Yeah. Goats are
Thank
very
you.
popular in Oakland.
Yeah, I know.
Thank you for the answer, and thank you for this amazing presentation.
Yes.
Thank you for attending. I'm glad you guys enjoyed it.